Section 2. Sample stability. So FAPAS is a truly international PT provider. We ship out our samples from our office in the UK to many countries around the world. Some of these countries are in the Far East or South America, and it can take several days for the samples to reach their destinations, even when sent by courier. So a valid question to ask is, are these samples stable for the duration of that transport? One specific question was asked to me recently by a laboratory in a Far Eastern country, and this was about veterinary drugs, in particular beta-lactams, in bovine milk. And in order to answer this question of stability, I looked at the data, and what we see on this slide are all the Z-scores from laboratories taking part that are a long distance from the UK. That is, the samples had to travel a long way. The countries and the territories that they went to are listed there, so they include China, Hong Kong, Taiwan, Costa Rica, India, Singapore, Thailand, and the USA. If there was a sample stability issue, we would see a trend in the data. That is, the results from all of these labs would be compromised in some way. But when we look at the data, actually the majority of them achieve good Z-scores, around about 0. There are one or two extreme Z-scores, but there is no trend. And if we look at the histogram for cloxacillin in this example, we see it is symmetrical and normally distributed. There is no evidence of instability for this sample. We can also do formal stability testing. This example is a canned meat test material for hydroxyproline, and we can do a stability test over a period of weeks, and this is the data that we might get from such an experiment. The samples are put at regular intervals into extreme conditions and then analysed against a sample that is stored at ideal conditions. And we can plot a graph, as we see here, which shows a slight downward trend indicating potential instability. But if we look at the half-life of this graph, we can see it's estimated at 123 weeks. That means it would take about 2.5 years before the level of hydroxyproline in this sample got to half of its level if it was stored at 35 degrees C. Clearly that's not going to happen, that's too extreme, so under normal storage conditions this is perfectly stable. We can also do very specific stability testing. Vitamins in particular might be compromised by stability. A few years ago we introduced our first vitamin C proficiency test in a fruit puree. In order to minimize the possible instability, we had a short time scale and a courier dispatch for this sample, even for countries close to the UK. We shipped the samples in insulated boxes, and we did an experiment where we had samples in an insulated box at 4 degrees C compared to the ideal storage conditions of -20. And we can see that over the period of time for transportation, so nearly 2 weeks, there was no evidence of instability at all. For our food microbiology samples, we actually stability test all of these samples over the course of the PT, which is a 4-week period. And again, we have all the data to show there is no problem with microbiology samples. Another specific example was for dithiocarbamates. These are very unstable pesticides, and in fact its analysis exploits that because it measures the release of carbon disulfide as the dithiocarbamates break down. A typical example would be Thiram. Again, before we released our first proficiency test on this, we carried out a levelling stability exercise. So you can see on this chart the difference in concentrations between samples stored at ambient conditions and those stored at 4 degrees C. There was an immediate drop in concentration over the first 1 day, that is 24 hours, but after that it clearly had stabilised over a 4-day period, which would be the normal period of time for shipment of those samples. So overall, we have high confidence in the stability of our samples, either through evidence of the proficiency test or through evidence of formal stability testing for particular cases.